Okay, so we can start now. Good morning, good afternoon, wherever you are. Thank you for coming to our webinar. This is the second in a set of 3 webinars this semester on the theme of big data and global development, which I'm co-organizing with Rob, Richard, and Tim Foster from the Global Development Institute. Quick intro, I'm Basma Banna. I'm a doctoral researcher at the Global Development Institute at the University of Manchester. I'm also a researcher at the Center for Digital Development. For the past 3.5 years of my PhD, I have been trying to develop and experiment a method that uses big data sources to identify and understand outperformance. I was lucky enough to be under the supervision of Richard Heeks from the Center for Digital Development and Julia Handel from Manchester Business School. And by big data here, I mean large data sets generated from digital devices and sensors like online data, mobile data, and remote sensing data, which allow for insights into people's behaviors, outcomes, movements, and choices. But the more you use big data, the more you'd realize that it has very limited value and meaning if it's not paired with context that can be found in more traditional data sources, such as official statistics, and in thick data collected through qualitative and ethnographic methods, which are better to explain the why and how of what we are able to observe using big data. In this webinar, we will present approaches that can be used to blend insights from big and thick data and other types of traditional data to form a more complete picture of the development challenges and the potential solutions. I'm honored to be presenting today alongside 3 brilliant speakers who used and experimented such methods and approaches in development. And before introducing our first speaker, I want to tell you how this session will go. So for the next 40 minutes, we will have 4 back-to-back presentations, followed by 30 minutes for questions and discussions. If you have any questions during the meeting, please put them in the chat and we will get back to them after the presentations are over. This session is recorded, so if you prefer not to be on this recording, please feel free to keep your camera off. And if you want to post your questions anonymously, you can send them to me privately in the chat. Our first speaker today is Mamello Tignani. He's a principal research fellow at the United Nations University Institute in Macau, where he leads the Smart Citizen Cyber Resilience Project. In his presentation, he will present cases that highlight the importance of data assemblages and affordances of different kinds of data, such as big data, thick data, and small data, towards integrative approaches to sustainable development. Mamello, it's all yours now. If you're ready, you can just share your screen.
All right, that's great. Thank you very much, Basma. Let me just get my screen sharing going. Okay, can you confirm you can see my screen?
Yes.
That's great, thank you. So thank you very much for the invitation to participate in this webinar. Very excited to be part of the discussions. I think at a very apt time that we need to be having these discussions. I titled my presentation, All Data Are Initially Equal, but we'll change that to important, but some data are more important than others. And I think this is, for those of you who are aware of Animal Farm, direct reference to the idea of how politics sometimes play a big role in shaping what we understand to be the relevance of, in this case, data. So I think, as I'll show later, and I think most of us understand different types of data are important to give us the nuanced understanding of development across different sectors. But the reality is that, of course, predominantly big data, different types of data get emphasized as more important, depending on who are the key stakeholders and the decision makers in those spaces. So I'll want to do, first of all, a high level reflection on this problem and share some examples from some of the case studies that I've been involved with, the project that we worked in South Africa. As a start, I always like this. This is from a play by T.S. Eliot. It's called The Rock. And it starts by saying, where is the life we've lost in living? Where's the wisdom we've lost in knowledge? And where's the knowledge we've lost in information? And I think this is important personally for me because it sets into perspective, why the information and the data that we collect what's the end goal of that. And so directly from there, you can see this very high level information value chain, if you like. How do we go from information, from data, and of course, different types of data? How do those combine to generate knowledge, which is when humans interact with these different types of data? And how do we enable intelligence out of that? How do we enable decision-making and problem solving at different levels and for different stakeholders? And ultimately, of course, towards life goals. And whether you're talking about SDGs as the life goals or at an individual level, we need to understand how does data and the different types of data contribute to knowledge, actionable insights. How do we use some of the technological tools around artificial intelligence, et cetera, to ultimately, for example, around wisdom, collective intelligence that enables individuals, communities, urban settlements, the whole global community to achieve some of these sustainable goals. And so referring back to my title, once again, the reality is that all these different types of data are absolutely important, and we need to figure out ways how to integrate those towards this continuum. And so I think it's important to spend time teasing out some of these terms that we use around data. There's a lot of them. Some of them I just discovered when I was preparing for this webinar. But it's important that we tease them out because sometimes we talk past each other. So for example, sometimes we talk about big data, but in reality, it turns out it's actually not big data, maybe because of the velocity or because of the volume or whatever. So it's always important that I think we tease out what are some of these definitions, what are the different types of data that we're talking about, and I think more importantly, what are the affordances of each of these different types of data and what can we do with it that allows us to achieve, of course, these sustainable development goals. And as you'll see here, some of these definitions are based on the type of data. So for example, attributes of data, either functional, non-functional attributes. So for example, think about structured, unstructured data, microdata. Sometimes also about the quality attributes. So good data, bad data. But some definitions will have to do with the source of data. So for example, sensor data, machine data, IoT data, all of these distinctions that we need to be clear about going forward. So I'll spend a bit of time just talking about a few of them, which in my work have been important. So I think, of course, good data, good enough data. There's a brilliant book that's written by Angela and Monique just around good data, about sometimes why good enough actionable data should suffice for developmental purposes. And so from that, of course, you can see that the key thing is that data is actionable, it's useful, it's about the utility of the data. Thick data, Basma, as you already highlighted, this is typically defined as qualitative ethnographic data. Now, if you're talking to anthropologists, they might have a different sense of what ethnographic data approaches look like. But I think generally, we accept that any data collected on the ground through engagement with the users, that's ethnographic data. Microdata, there's also talk of small data sets. We've got real-time data as well, timely data, live data, or streaming data. In our work at UNU, we've spent a lot of time looking at small data. And within that, there's actually been quite a few different definitions that we've come across that I'll share a bit more in detail. And of course, as you indicated already, big data, which tends to dominate the discussions around data. It went all the way from the 3 Vs to the 5 Vs to the 7 Vs of data. The definition keeps changing all the time as we get more and more data. And of course, ultimately, that as well will change to the point where we get humongous data, right? So increasingly, we're getting more data. Increasingly, our computation and analytics are increasing. So what is big data today might not be such big data in the future. So, but I think at a very high level, that highlights some of these different types of data that we deal with in different contexts, including for development. As I said already, in our work, we spend a lot of time thinking about small data. And I'd just like to share with you some of the key definitions around small data. So one is around actionable byproducts of big data. That's Bonda's definition. Deborah Estrin defines small data as data where n equals me, so focused on the individual. Michael Best defines it as an approach to data analytics. And ultimately for us, it was an approach that centers individuals within data collection processes. And you can see, of course, within the SDG processes as well, there's already this awareness of the need to integrate both aggregate macro level data analysis as well as citizen-generated data, individual level data, and macro level data. So we can see that movement as well within the SDG data collection communities. I'm going to spend the second part of the presentation just talking about a project that I was involved with in South Africa, which is around social accountability monitoring. This is the Mobisang project. This is essentially around digital citizen engagement, so enabling citizens to hold government accountable to service delivery. And within that, talk about the different types of data that was collected and how that was used and the benefit of that different type of data for different stakeholders. So this actually comprised a couple of things. There was Twitter data, there's Facebook data, there's also currently WhatsApp groups, and of course, offline engagement. But predominantly, there's a platform that was developed to enable citizens to report these service delivery issues. So for example, citizens are able to go online, they can check what are the issues around their neighborhoods, they're able to report the service delivery issues, and then in that sense, interact with the local government in a way that goes from reporting an issue to its ultimate resolution. And at a very quick glance, you can of course see the different types of data that we're collecting in this project. So all the way from unstructured descriptive data around the issue that they're facing. We've got graphics, we've got geographic location data, and also conversations that happen, of course, between the individuals and the government stakeholders. I'm not so bold as to say that we're dealing with big data. So even though we're dealing with Facebook data and we're dealing with Twitter data, it's not the level of volume or velocity that would typically constitute what's called big data. But in terms of the analysis, of course, we have used some of those approaches that would equally apply. So just looking very quickly, what are some of the uses and some of the ways that this different data has been used? Of course, at a very general level, the typical aggregate analysis and reporting. So around what kind of issues have been reported, both at an individual level and across the whole municipality. And predominantly, it's really just been this idea of enabling service delivery. So the municipality being able to have a snapshot of where the issues are happening and then be able to send out people to resolve those issues. But we've seen other uses as well. So for example, awareness raising at an individual level. So where individuals are aware, first of all, of the issues within their neighborhoods, but also more engaged in terms of demanding their rights to be respected. We've had cases where data has been requested for us to support litigation, where the municipality has been taken to court. And of course, advocacy and collective action. And so you can see the aggregate data analysis as well as some of this textual discussion between individuals. We also get, of course, data that maps the issues geographically. And a lot of this is really being used to support stakeholder engagement, but also follow up from the ward councillors who are then able to engage at the ground to understand what are some of the issues, why are issues not getting resolved, and what are some of the bottlenecks towards service delivery. And beyond that, we've also done, of course, some text analysis based on the text that's recorded on the platforms, including the text that's recorded through comments on Twitter, as well as on Facebook. And at a very high level, this just gives us an understanding of, of course, sentiment analysis and topic modeling to understand, first of all, what are some of the key discussions that are happening around service delivery. And beyond that as well, the sentiment across the different text data that we're collecting as well. So to wrap it up very quickly, and of course, I'm happy to talk a bit more in detail about the experiences within this project. I think it's important to recognize, as I said at the beginning, that the politics of data dictate what types of data and what data approaches typically get emphasized and prioritized in these projects. So if the key stakeholders are government stakeholders who are interested in aggregate data, that might be the data that gets prioritized and highlighted. So I think it's important, as indicated in this case, to map out and understand how different types of data support different stakeholders. So in our case, we are working with CSOs who might rely more on the granular contextual data to be able to follow up, and not so much maybe on the aggregate data. And I think it's also important to understand that you can have different integration approaches. So both in terms of using, let's say, big data and thick data in parallel to support different stakeholders and to support different ends. But I think you can also have approaches where you triangulate and you use thick data approaches to support insights that are coming from big data or vice versa. And I think back to the point that I said at the beginning as well, I think it's important that we speak the same language, especially when you have people from different disciplines undertaking work in these spaces. Sometimes we talk past each other in the terms that we use. And ultimately, the last point, I think, once again, links to the first point that I said, the importance of the data assemblages within which these projects and these activities take place. Ultimately, as we all know, data is not data. Data is shaped by all these contexts, so the social context, political context, technical context. And I think all of those ultimately shape what is valued and what becomes prioritized. So in a quick note, that's the overview of the presentation. I'll be happy to talk a lot more in detail and take any questions that come from as well. Thank you.
Thank you, Mamalo, for the great presentation, which really sets the stage for the following presentations. Again, I would like to remind our participants that if you have any questions, please post them in the chat and we will be able to discuss them at the end of the presentation. So our second speaker is Macy Angelina. Macy is the Social Systems Lead for the United Nations Pulse Lab Jakarta. And in her presentation, she will highlight real-life applications of how in Pulse Lab Jakarta, they're mixing insights from both big data and thick data. So Macy, it's all yours. Yes, yes.
Okay, wonderful. Hi, everyone. My name is Macy Angelina. I work in Pulse Lab Jakarta, and I'm speaking from Jakarta, Indonesia. Very nice to meet all of you. So I'll be sharing some of the real-life applications of both big data and thick data when it comes to addressing real-life development problems that we encounter in our work in Pulse Lab Jakarta. Okay. So first of all, an introduction to the organization I am part of. Pulse Lab Jakarta is part of the United Nations, and it started in New York, but soon enough, the government of Indonesia realizes the importance of having this lab in our own context, so they have been co-hosting our entity since 2013. The original mandate of Pulse Lab Jakarta is to look at how can the development sector, particularly the UN, looks at all of the mass of big data, unstructured data that comes from the private sector mostly, and use it for development purposes to provide real-time or predictive information that can be used to address development and humanitarian problems. But quickly enough, we also found out, as Basma said in her introduction, that big data alone is not enough to provide us with some insights that we need to address those complex development problems. And so that's when we turn to thick data. So to give you an overview, this is the range of data sets that we have worked on since 2013. And as you can see, there's a lot of different kinds of data, social media, crowdsourced data, geospatial data. But I'd like to draw your attention to 2015, because this is when we started using qualitative data sets. And that's when we really started our journey in the lab to really think about how different kinds of data can form insights that actually are actionable and can contribute to solving development issues. So very quickly, what do we mean by qualitative data in the context of our work in Pulse Lab Jakarta? It is data sets that are produced by rapid ethnography, human-centered design, and political economy analysis. So we in the lab categorize them as two different types. The first one is the thick data that Basma and Mamelo have mentioned in their presentations. So this is the kind of data that provides insights into things that cannot be quantified, like people's emotions, desires, and mental models of their world. And usually we translate this data into insights, archetypes, or personas that aid into the design of solutions, design opportunities, or prototypes. But at the same time, there's a different kind of qualitative data that we worked with, and it's called qualitative relational data. So this is the kind of data or information or insights that we need to understand how a system works, how we can identify its parts, and also the dynamics and the relationship between these parts of a system. So the outputs would be systems mapping, surface blueprint, and the like. This is some of the ways in which our lab has combined both of this big and two types of qualitative data. For the combination of big data and thick data projects, we've applied it in three different contexts. One is around the identification of hotspots during haze crisis in Indonesia. The second one is about identifying rural to urban migration, especially for seasonal ones. And the third one is around behavioral science experiments in order to improve financial inclusion. And in these three contexts, the big data parts come first, and the thick data parts or the ethnographers are being sent in to really find out the dynamics and nuances to explain some of the strange things that have come up in the analysis of the big data. In the bottom part are some examples about how we've done big data and qualitative relational data projects. So in Pulse Lab Jakarta, we are often asked by government counterparts to create some tools that extract information from different kinds of data sets in order to inform decision making. But technical proof of concept is always just one thing. The bigger and more complicated question is always, how do you embed them into existing modes of decision making and existing systems? And how do you make sure that they don't gather dust somewhere in the corner of a government office, but can actually become embedded in their system and become usable? So this is where the social systems team, what I'm part of, comes in. So what we do is that we do user research, we do systems mapping to understand the political economy of a particular part of government agency, understanding how the systems work, what are the functions of the people, to also understand where we can embed some of these technical solutions and figure out the ways in which to make sure that the implementation environment is conducive to make sure that what we have come up with as a prototype or proof of concept can be applied in real life. So I'm speaking as part of the social systems team, or the team that hosts the ethnographers and also the design researchers within the lab. And we are the ones that contribute the thick data and the qualitative relational data into the projects. And that's the lens from which I'm speaking. To give you a more concrete example, I'm going to focus on a particular project that we just wrapped up in late last year. It's called Pantau Udara, or Community-Based Air Quality Monitoring. So this project came in its genesis as a request that came from two partners of ours, the Bandung Institute of Technology, which is a university, and also Copernic, which is a local non-governmental organization. So both of them came to Pulse Lab asking for technical assistance to be part of the project that tests whether low cost sensors can actually be used to help community members monitor the air quality in their environment, especially at the village level, and to see whether this is actually a better alternative to some of more expensive alternatives that government usually have access to. So we are interested in the idea in the beginning, but we also said that it's really important for us to not only think about the technical part, which a lot of people would use as a starting point. So in a lot of different projects, and also this is what we ourselves have done in the past, we're going to jump directly into the technicalities of how do we source these low-cost air quality sensors, what kind of air quality index computing platform can we actually come up with. But now that we have worked with tech data for a couple of years, we understood that the initial question you should be asking is that, first of all, where do you want the system to live? What are the ecosystem in which the system wants to live, and what are the community perception and existing systems there are when it comes to air quality monitoring, and what are their perception around air pollution? So instead of starting with that more technical big data part of the project, what we ask is whether we can spend some time in areas where Copernic and Bandung Institute of Technology wanted to do this pilot to understand the community perception around the issue of air pollution, and understanding also the systems that are already in place in the village apparatus to communicate issues around health or emergencies. So that's how we started the project, not with the technical part, but with the user research and systems mapping. And we found a couple of things. First of all, we found that actually communities don't think of air pollution as a very salient, urgent, important project, because air is something that they experience every day. And this is not like an emergency like flood, for instance, that they know is something that is ongoing, incoming, and they have to immediately respond to. So there's a lot of work that needs to be thought about as well in order to make this a salient issue for the community to respond to. Secondly, we also found that in similar cases in the past, for instance, nutrition, it's really the village apparatus that deals with health, especially the cadres or the local facilitators in the village. They are the ones with the most ability to influence community members to understand that these are important health issues and actually do something about it. So we also mapped the way that existing health cadres and health apparatus communicate these kinds of health issues and use that as an inspiration to think about a community action plan where the air quality sensors and also the resulting air quality index computing platform can be embedded with. So once we have that, we went into the second step, which is to design a low fidelity prototype of that computation system and also the action plan where we work with the village apparatus to communicate with the community members. And we brought that concept back to the villagers, both the government and also the community members, to get their feedback and see where do we have to make tweaks. So once we have tested that, that's when we started testing the installation of the sensors and started working to test the computational model. And afterwards, we started installing sensors to collect data. And afterwards, we went back to the community to test and refine the high fidelity prototypes and action plan. And finally, once that part is done, that's when we hand over to partners and communities. So again, thick data in this more applied context is something that is embedded along the way. It's not something that we focus on only in the beginning of the project, for instance, but it's weaved into different stages of the project to make sure that both big data and thick data are combined into making an intervention that is needed and can be well responded to by communities. So that's some of the examples from real life work in the lab, and I hope that the air quality monitoring example can give you a more concrete idea about how we integrate these kinds of data sets within our own lab. But if I can also share one takeaway in true ethnographer's fashion, I'm not going to talk about the technical parts of the data so much, but more about the human part. So sometimes the hardest part of integrating two different worldviews are the humans, right? How do you get people out from silos and actually into working together? And for us, our one main takeaway is the importance of assembling teams. So what you see on the left-hand side, this organizational structure, is how we organize ourselves within Pulse Lab. The data engineers, the data scientists, they sit in this data innovation and policy team. I lead the social systems team, and I have design researchers and ethnographers working with me. And there's another team that's called partnerships and advocacy. And the role is really to lead the project management and work with partners and understand that political economy angle when it comes to collaborative partnerships. So in the past, usually we don't have a designated project team, and we just huddle together and think about what can we do if a problem comes and we want to solve it. But what we have found recently is that it's healthier to disassemble this kind of organizational structure and create a project team with a designated project lead who is authorized to be making decisions related to the project and lead the engagement with change makers and partners. We get project team members and advisors that comes from all of these teams. So it's very important for us these days when we start a new project to start from scratch. Each of these teams delegate members to the project team. We have a very clear project lead assigned, and we also have technical advisors in place. So decision-making structures are quite clear, and it's easier as well to really think about how we can brainstorm together and bring our expertise into the table. So in a nutshell, that's some of the experiences from Pulse Lab Jakarta that I would like to share. Hopefully this is useful, and I'm happy to share more as we go into Q&A. Thank you.
Thanks a lot, Macy. This was definitely very useful. Our third speaker is Alex Ornston. He's a data scientist and a geographer at Descartes. In his talk, he will explain how he combines participatory mapping with remote sensing to understand seasonal livestock movements and the responses to drought. I will hand on now to Alex.
Okay, here we go. Can everyone see my my screen?
Yes, yes.
Great. Okay. So again, yep, sorry for the delay. My internet connections here kind of leaves a lot to be desired. So I appreciate your patience. So yeah, my name is Alex Orenstein, and I'm a data scientist here in Dakar, and mostly what I work on is mapping herd movements and understanding how those movements change in reaction to drought. So I'm going to try to keep it to as close to 10 minutes as possible here. But if there's anything that's not clear, I'm happy to talk about it later or questions or. So a little bit about what we're talking about today. We will be talking about how to use a combination of remote sensing data and participatory data to understand the movements of pastoralist herders. So when we're talking about herders, pastoralist herders, we are talking about a population of about 50 million people in the Sahel who depend on livestock for their livelihoods. Now, a lot of these people are mobile. They have to move with the seasons to find pasture and water for their animals and thus for their livelihoods. And the place we're talking about is the Sahel. It's this very large band that stretches from Senegal in the west to Chad in the east that you see in the map in the top right-hand corner of the screen. So in order to understand transhumance and the movement of seasons and the herds, we have to understand a little bit more about the seasons. So I've made a seasonal calendar. You can see it in the top right-hand corner of the screen. And it sort of gives a breakdown of how movements work during the year. So we have our rainy season in the Sahel from July to October, and that's the only rain we get throughout the year. And starting in November till about June, these are the two dry seasons, and that's when the movement happens. And this is when herds have to move. So to give you an idea of what this entails, if you look on the bottom left, you can see an image. And this is of a lake area in central Mali in Mopti. Now on the left is an image in September, right? This is the end of your rainy season. Everything is lush and green. On the right, this is the exact same spot, but in May. So you can see pretty clearly how it goes from lush, green, and verdant to dry and desiccated within the span of a year. And this is a regular year. This isn't a drought year. This isn't a year where things are particularly dire. Or to use a remote sensing image, this is a lake in northern Senegal in a place called Canel. And this is one of my favorite images to use to show seasons because you can really see how the lake explodes in the rainy season, right? And then December, January, February, it shrinks until there's pretty much nothing left by June. This is a regular year. This is a regular period. And this is what herders, what pastoralists are subject to every year. So movement and mobility and being able to move their herds to find pasture and water is pretty critical. So when we're talking about transhumance, the movement between seasons, what does it look like? So this is a map prepared by the OECD, and I quite like this map because it shows a whole bunch of different types of movements that herds undergo. Long movements towards commercial centers, small movements over maybe 50 kilometers. And, the big takeaway that I want from this map is that transhumance is heterogeneous, right? You've got millions of different herders that will move for just as many reasons, right? You have a very large variety of different herds that have different motivations, different reasons for moving, and different styles of moving. So it's not it's not a homogenous type of movement. And I think that's really important to keep in mind. So why is it important to understand movements? So the first, and from the perspective of humanitarian aid, is that seasonal food insecurity hits pastoralists first. So on the right, you can see a graph that shows average rainfall, and in a very thin line behind it, you can see severe seasonal acute malnutrition over the season, and you can see that severe acute malnutrition really peaks about a couple of months after the rainy season. This hits pastoralist communities first, right? These are people who depend on naturally occurring pasture and water for their livelihoods. If it doesn't rain enough, if pasture doesn't grow, if lakes are depleted early, then pastoralists feel this first. Now, as you can probably tell, transhumance is a fairly nuanced system, right? There's a whole lot that goes into it. And you'll probably not be surprised to find out that the humanitarian sector doesn't really do nuance very well and is not really known for nuanced understandings of these sorts of systems. So as a result, pastoralists are traditionally underserved by the humanitarian aid sector. This is a mobile population, and as a result, traditional humanitarian aid finds it pretty difficult to geographically target things like food distribution, cash transfers to these groups of people. And it's important to understand movements because without it, you can't do targeting. You can't anticipate drought. And being able to anticipate transhumance can help improve land use planning and avoid a lot of the land use conflicts that we're seeing right now in West Africa. So zooming out, putting it into perspective, okay? We can understand drought. We can forecast drought. We've been, we've had GIS has had, the technology to be able to do this for like 30 years, right? This is a map that shows basically drought in West Africa. It's biomass growth during the rainy season, where vegetation grew, where it didn't. Red are the drought areas. Green are the areas that had an excess. So, all right, we can image drought. We can see what drought looks like. But how do we know where to look, right? If we are trying to develop systems and products that better serve pastoralist herders, that better, serve their needs during droughts, how do we know which areas are important, right? The Sahel is quite a large space. We can see red happening in some areas. Are those places that are most important for herders? How do we find that out? And this is where you get to the question of how to map the movements, right? It's a very complicated system, but it's spatial in nature. So how do we get that onto a map, and how do we compare that map to satellite imagery to see, if herders are moving into drought territory, places where there's drought? So the first one, and this was something that I tried. So this was something that I tried many years ago over a number of iterations, was using GPS trackers, right? Seems pretty straightforward. It's, how a lot of it is done elsewhere, and, how wildlife trackers look at the movements of endangered species. This did not work. We found it almost impossible to get a statistically significant sample of herders. We found it difficult to arrange for tracking over several months. And likewise, a lot of people were really uncomfortable with, having their herds tracked like that. So GPS tracker out the window. Now, remote sensing, satellite imagery. Most of my work is on remote sensing. So naturally, I gravitated towards the idea of using satellite imagery. And while it's true that satellite imagery can provide you a nice snapshot of what's happening, it's not really feasible yet to do this over a large space. Like right now, you can do it over a small space, but scaling that up is pretty cost intensive, pretty labor intensive, and takes a long time. So in the context of a humanitarian disaster, remote sensing didn't really work. Then, of course, there's drones, UAVs, right? That's one of the, buzzwords that we're all into now is using UAVs. Unfortunately, for the Sahel, not really a workable context. Um, drones don't really have a great connotation in a lot of places where there's an ongoing conflict, and also major privacy issues, and of course, the logistics of actually getting the drone out there. And then we come to AI machine learning, right? This sort of seductive narrative that if we just put all of our, data into this black box, into this, sausage machine, then it will come out as something usable. But unfortunately, garbage in, garbage out. When we find ourselves with bad input data, it doesn't really matter how great your algorithm's going to be. You're just going to get crap coming out. So this left us with the Sharpie. And we ended up moving towards a system of participatory data where herders, communities of herders would get together, and we would simply draw a map of where the movements were going. We would ask questions, we would talk, we would promote a discussion, and we would learn about how these worked and what happened. So this ended up actually being the most workable solution, because you look at something like a remote sensing image that might show you where cows are, but you don't know the story behind why those cows are there, right? Is this a normal movement? Are they planning on staying? Are they in transition? You can't tell that with a remote sensed image. You can't tell it with a satellite image, but you can if you know the story. So we were able to map these out, have a community discussion to find out, okay, are these normal movements? Are these emergency movements? Are you moving in reaction to a drought? Are you anticipating a drought? And so on the top left, you can see this was the mapping session, one of the many mapping sessions we had. And then on the right, what that looked like is the product. And then the bottom left, how that turned into a digitized product. And on the bottom right, compared to satellite imagery. So we could see how those movements compared to the current image of drought. So what were the results? Well, this was a foundational data set that's still used right now for pastoral early warning systems and climate information services all across the Sahel. One of the things we learned was to really question accuracy versus precision, right? We did not settle for a precise product, but we settled for an accurate one that we felt told the story. It didn't get it down to the meter, but for what we needed, that wasn't important. Then the fact that you have to center the user and participant. I find that participatory and qualitative data are oftentimes sidelined in favor of big data, especially by the humanitarian community. We treat participatory data as a window dressing, right? As something to get nice quotes out of for our report. But what I want to know is, if you don't know the story, what is your data going to tell you? Which then leads into the second question, is who makes the map? The humanitarian sector is very fond of top-down approaches where people outside of the problem are making the map. But when you don't have participation, the people who are supposed to be impacted by this product are kind of left voiceless. And I realize I'm a little bit over time here, so I'm just going to end it with this last quote of Earth observation is a powerful tool, but it simply cannot replace local knowledge. So thank you very much. I appreciate your patience. And yes, happy to connect if you have any further questions or if you want to talk more about this.
Thanks a lot, Alex, for the great presentation. Yes, we're running a bit out of time, but let me see what I can do in 10 minutes. So hi again, everyone. Today I will be talking to you about the data-powered positive deviance method, and which is the PhD research I've been doing for the past 3.5 years at the Center for Digital Development, and how we are experimenting and refining this method with development partners as part of the data-powered positive deviance initiative. Just to begin, what is positive deviance and from where all of this started? So positive deviance is based on the observation that in every community, there are individuals or groups who are able to achieve better outcomes than their peers. And those individuals are referred to as positive deviants, and scaling and amplifying their practices is what is called the positive deviance approach. The success of the positive deviance approach can be largely attributed to Jerry Sternan. Jerry Sternan applied it as a strategy to reduce malnutrition in Vietnam. And by scaling the practices and strategies of mothers of extremely well-nourished children in extremely poor villages, he was able to rehabilitate an estimated 50,000 children in 250 communities. And this was a huge success, which kick-started the adoption of the positive deviance approach in different domains, including enhancing school retention and limiting HIV transmission. But the growing availability of digital data sets that are able to capture the outcomes of individuals, groups, and spaces, and the increasing datafication of development provided an opportunity to ask the question, which is my PhD research question, of how can we leverage the positive deviance approach using big data? And in order to answer this question, it was important to identify the limitations and opportunities of using big data beforehand, which are detailed in this paper that I co-authored with Richard Hicks, my supervisor. And here we are identifying a number of opportunities, including the hope for reduce in time and cost of data collection. So the positive deviance approach relies mainly on primary data collection in order to create the baseline from which outliers are identified, something that includes significant time, cost, and risk. And big data, which is readily available at a low cost, can be used as an alternative to reduce those costs. Another problem is that since the sample size is a function of the time and cost is a function of the sample size, positive deviance samples are relatively small. And because they are small, the number of positive deviants identified, which is the exception or the outlier, is small, and it's harder to make generalizations of conclusions. Big data will enable us to have a larger number of PDs, hence being able to generalize those conclusions. It also enabled us to look into levels of aggregation that are beyond individuals because of its large spatial coverage. So you can look into the outcomes of groups or communities or regions instead of just focusing on the outcomes of individuals. And something that we came to realize as we're applying the positive deviance is expanding the scope of positive deviance. So instead of looking into individual factors that are driving performance, it is possible to look into supra-individual factors, factors beyond individuals, such as policies or development interventions or governance schemes that are happening there, and seeing their effects on the intervention population. But there are limitations of big data that all of the previous speakers spoke about that big data, thin data. It is covering only one dimension of performance. It's usually designed to capture outcomes that aren't not necessarily the same outcomes that we're looking into. And as it's able to explain the what, it's not able to explain the why and the how. And hence, it became extremely important for us to realize the importance of combining both traditional and non-traditional data sources in order to identify and characterize those outperformers. And just to compare like positive deviance and data powered positive deviance, here we're using traditional data, here we're using traditional non-traditional data. In positive deviance, we're relying on a manually recorded performance measure. In DPPD, we're relying on a digitally recorded or observed performance measure. Positive deviance where it follows a cross-sectional design due to the costs and the time of collecting data at certain points of time, while big data, because of its longitudinal coverage, it enables us to observe performance throughout time. The unit of analysis moved from being individuals into being individuals, groups, and geographical units. And the PD explanators moved from just being individual-based factors, but also in the DPPD, we're able to look into individual and supra-individual factors. So just to give you a summary of how or what are the steps that we undertake in order to do or identify positive deviance and understand them. So the first step is the problem solution fit. So positive deviance is not suitable for all problems. It's particularly suitable for problems or adaptive challenges that require a behavioral change. So if you can solve this issue with a technical solution like building a bridge or just installing irrigation, that is not a PD suitable or PD amenable problem. The second question is, will DPPD be a suitable fit for this problem? And here we have to ask questions regarding the feasibility. Do we have access to the data and the capabilities that will make it possible? And we have to also ask about the desirability. Are we doing harm to the observed units? Are there any negative unintended consequences from applying DPPD for this problem? The second stage, after ensuring that this is a good problem and like a PD suitable problem and DPPD is a suitable solution, would be determining and identifying positive deviance. And to determine and identify positive deviance using DPPD, we have to first find a reliable and relevant performance measure that is digitally observed and recorded that could cover our study population. But the problem with digital performance measures that they are, and due to their large coverage, there is a lot of underlying heterogeneity. In order to reduce this heterogeneity, it's very important to dissect and divide this population into homogeneous groups that are having somehow similar structural and contextual factors. Why? Because when we identify PDs within those homogeneous groups, we don't want them to be driven by those structural factors, but instead we want to make sure that the performance is due to individual and behavioral practices and not due to structural factors. The next stage would be to identify PDs within those homogeneous groups. And with big data, there is noise, and that's why it's extremely important after the identification to do the PD validation before deciding that those potential positive deviants are worthy of a visit and the costly the costly process of collecting data there and doing the qualitative inquiry. So you can look at it as a funnel. You start with large study population, and then you go down into a smaller population, which is the homogeneous group. Within those homogeneous group, you identify PDs, you validate PDs, and then you start the qualitative PD inquiry. It's also similar to the use of traditional and non-traditional data. So at the beginning, there's an extensive use of non-traditional data and less use of traditional data. But as you go down, you would need more traditional data to validate and filter the noise. After the problem solution fits comes the stage of the fieldwork. So you go there, you start to uncover the underlying practices and the underlying factors leading to positive deviance. And this is like an initial framework that we used in the positive deviance and research performance case that I will be explaining in the following slides. We start by looking into PDs and trying to generate tentative hypotheses of what they're doing differently. In this case, we cannot just rely on the literature, but because we're assuming that there are innovative solutions that are applied and adopted by those PDs. So it's important to go there and do an inductive approach in order to identify those tentative hypotheses. After developing those tentative hypotheses, those hypotheses are added to predictors from the literature to develop maybe a questionnaire tool that is covering a larger population of PDs and non-PDs in order to have significant predictors, statistically significant predictors of PD performance that then could be used to inform interventions that later on will be monitored and evaluated. So the Data-Powered Positive Deviance Initiative and the Data-Powered Positive Deviance Initiative, the Center for Digital Development, represented Richard and I, worked along with other partners like the GIZ Data Lab, UNDP Accelerator Lab, and Pulse Lab Jakarta in order to experiment this method in different domains and different countries. Among those methods, Egypt was the first case, which was during my PhD. And here we reached the point of identifying significant predictors. And other following projects were in Mexico, Niger, Ecuador, Somalia, and Indonesia. All of them are at the stage of PD validation now. So we identified the PDs and we are validating them in preparation for the fieldwork. So quickly talking about the Egypt case. So in the Egyptian information systems case, we're looking into researchers that are able to achieve better outcomes than their peers, measured through 6 citation matrix, the H-index, HC-index, M-quotient, and other relevant matrix of research performance. And we started with a sample of 203 researchers that went down to becoming, to identifying 26 PD researchers. We used Google Scholar citations in order to identify those PDs. So that was the non-traditional data source. And then the next stage was to interview 20 of those positive deviants in order to generate those tentative hypotheses. After that, we did a survey of 90 researchers, including both PDs and non-PDs. And here we used more traditional data sources such as surveys. And following that, we started to think, how can we leverage digital data and non-traditional data also in order to identify predictors of performance? And in that case, we used the corpus, the publication corpus of PDs and non-PDs in order to identify those significant differences between both groups. Some of the significant differences that we identified was the importance of multi-country research teams, publishing with foreign reputable authors, There were also things that are related to extrinsic paper features, like the length of the paper and the title, the length of the title and the abstract and the number of references, and taking courses such as scientific writing and English language courses. We also did some big qualitative analysis, like topic modeling, in order to identify topics of PDs versus topics of non-PDs by using unsupervised machine learning techniques on their abstracts. To take you quickly into the other domains that where we applied positive deviance with partners. So we applied the same approach in agriculture with Pulse Lab Jakarta and the UNDP Accelerator Labs and the GIZ Data Lab, in order to identify in Pulse Lab Jakarta in Indonesia, the rice farming villages that are able to achieve higher than predicted yields using remote sensing data. So we used EVI. It's a remote sensing derived vegetation matrix that it could be a proxy of yields if we used a certain measure, which is the max EVI. And we try to control as much as possible for different agricultural and socioeconomic factors that could be driving the performance, because again, we're interested in the residual, the difference between what is predicted and observed that is not explained through the model. We applied the same approach in Niger, but we looked into cereal farming or cereal growing villages in order to identify PDs. And here you can see those red dots are the PD villages in Niger, and here the blue polygons are the PD, potential PD villages in Indonesia. We applied DPPD in deforestation, where we looked into cattle farmers who operate in the zones of the expansion of the agricultural frontier, and they are not deforesting despite the pressure to deforest. And we used Landsat 8 satellite imagery to observe those changes in forests within the farm boundaries. And the control variables we use, because it's very hard to just look at forest change in absolute sense without looking into it in a relative sense. So in order to look at it in a relative sense, it's important to know what's happening on the ground. And that's why it's important to know the cattle density. And we used traditional data such as cattle, the vaccination data, the cadastral data in order to identify the farm boundaries. And in that case, it was possible to identify which farmers are able to deforest less despite the pressure forced by the cattle density there. And here we can see in the canton of Hoya de Sacha in red, the farms that were identified as potential positive deviants. The next domain or the next application was applying DPPD in rangelands. And here we looked into positive deviant communities that are having enhanced rangeland health. Since the last drought in 2016-2017, we used remote sensing data initially to identify this enhanced vegetation for those rangelands. And the next step would be to go into those communities and try to apply more of a qualitative approach in order to understand what are the factors that led to having them as positive deviant rangelands. And here you can see the ones in the red are the ones who are having degraded rangeland health, and the ones in green are the ones who are having enhanced rangeland health. This is an application where we applied also DPPD in urban safety, where in Mexico City, we're looking into areas that are having crime rates that are lower than what is predicted. And in order to predict that, we used socioeconomic and demographic data along with traffic data. And our performance measure was derived from open data sources, which is the crime investigation reports in CDMX open data portal, and using the 911 calls. So to sum up, the key learnings from applying DPPD in different domains was leveraging the right know-how. So it was very important to have this mix of domain data and local know-how throughout the application of the DPPD. So we needed this very specific country-specific domain know-how in order to identify if PDs exist, what are the contextual factors driving performance, and how can we make sure that we are looking into homogeneous groups. In order to also control for those different contextual factors, it's very important to apply DPPD in context-rich data environments. and make sure that we have traditional data that are overlapping both temporally and spatially with our area of investigation. When it comes to PD validation, it's extremely important to validate PDs before going to the field, and that is as important as identifying PDs. And again, there is an opportunity in using Earth observation data, because Earth observation data has is the most, and it turned out to be a very accessible and useful data source in order to identify PDs in most of the pilots, because it reduces the limitations of accessibility that we face in the other pilots, and also it enables us to leverage the potential value of using large spatial coverage and large temporal coverage. I'll end the webinar here, and I'm thanking a lot the audience and the participants for their time and for being with us today. And I wish you all a very good rest of the day. Thank you.